When solving a linear constant coefficient differential equation, we assume the solution in the form of yx equals erx. Let's differentiate that once. So you're going to get rerx. Let's differentiate it again. R squared erx. We can now substitute each of these into here, into the left-hand side, which is the homogeneous part. And you're going to get r squared erx plus 5 RERX plus 6 ERX, which equals 0. If we now substitute out e to the rx, you're going to get r squared plus 5r plus 6, which equals 0. And now if we divide both sides by e to the rx, it disappears. This isn't always necessary. You can just take this and you can know that that's r squared plus 5r plus 6. But then what people tend to do is they say, well, where did the x go? How did it vanish? How did it just disappear? This is why. So you don't need to do this every time when you just see it. You can just convert that into a quadratic. Let's now solve it. So that's going to be r plus 2, r plus 3 equals 0. So therefore, r equals minus 2 or minus 3. So the general solution for the homogeneous part would be some constant e and then the number here. So let's do minus 2t plus c2 e to the minus 3t. So these are the two numbers that we want to find, and we have found them. So that's the homogeneous part done. Let's now do the particular part. So again, this is something that you need to just remember. xp, which equals a to the e to the minus t. This is the general solution, the particular solution, sorry, of this form. So let's now differentiate this once. You're going to get minus a to the minus t, and let's differentiate it again. It's going to go back to the original. We can now take each of these parts and substitute them in to the left-hand side, but make sure we equal it to the right-hand side. So you're going to get a e to the minus t plus 5 minus ae to the minus t plus 6 ae to the minus t, and that's going to be equal to 2e to the minus t. Let's now divide everywhere by e to the minus t, and that's obviously going to get rid of these chunky boys here. So now you're going to be left with a minus 5a plus 6a, which equals 2, rearranging, and then we'll find out that a equals 1. Thus, if we take our a equals 1 and shove it in here, xp would be e to the minus t. Then we've been given some solutions when t equals 0. So let's plug those in. We'll have x, which equals xh, the homogeneous part, plus xp, which is the particular part. So it would be represented as c1 e to the minus 2t plus c2 e to the minus 3t, and then we add the particular part, which is e to the minus t. We know when t equals 0, x naught would be, when t is 0, that's 0, that's 0, that's 0. So therefore, it would then become c1 plus c2, which equals minus 1. That could be our first solution, so we can just leave that there. And then we'll have x differentiated once here, which would equal 2. So we can now shove that all in, and you're going to get minus 2 c1 e to the minus 2t minus 3 c2 minus e to the minus 3t. Sorry, I've just differentiated this once, obviously, minus e to the minus t. So we've differentiated it. Dx dt is 2 when t equals 0. So we can now plug that in. So when t is 0, the solution equals 2. So we're going to get minus 2c1 minus 3c2 minus 1 equals 2. So that's going to be minus 2c1 minus 3c2 equals 3. That's our second. That's our first. We can now just sub 1 into 2. So I'm going to make it in terms of C1. So C1 would be -1 minus C2. So 1 becomes C1 equals -1 minus C2. Let's plug that in here. So you're going to get -2 minus 1 minus C2 minus 3C2 minus 1 equals 2. We can add the 1 to that side. We can move it around. So you're going to get 2 plus 2C2 minus 3C2 equals 3. And then C2 is going to be -1. So if C2 equals -1, then C1 would be 0. If we plug C2 in here, it's just going to be 0. -1, you add -1 to both sides, add 1 to both sides, and then obviously that would become 0. So let's now take our solutions for C1 and C2, slap them into this top part here, and you are going to get x equals e to the minus t minus e to the minus 3t. So this right here is our solution. That looks horrific because I've put a line through my beautiful box, but pretty good.